this Falcon 9 rocket. Now T-minus 17 minutes, 7 seconds and counting. Coming up on the end of the big vent here. As that begins to taper off, we're now less than a minute away from second stage LOX load beginning. This is the final fueling step that has yet to start. We should be hearing a call out for the beginning of that in about 40-ish seconds.
Stage 2 LOX load has started.
As the big vent wrapping up there, we did hear the call out for stage 2 LOX loading, now in progress. Just taking a look at the live chat, seeing some of the chatter in there. Sounds like it's a bit of a chilly night by Florida standards. Our Michael Kane chiming in saying, can't feel my hands and it is so cold. Well, hopefully we've got some hand warmers out there, Michael. I know Adam was bundled up. I want to thank our friend Chuck Briggs for this great view of the Falcon 9 here. Now T-minus 15 minutes, 17 seconds from the planned liftoff. Chuck, Adam, and Pete Carsons will be tracking the rocket once it leaves the ground here. I also want to take a moment to thank our wonderful moderators in the live chat. I see Stephanie B joining us in there from Australia. So, g'day, Stephanie. Glad to have you with us. And Janine, who has been a channel member for 3 months. With a brief but concise yippee. Now, the PACE mission, as we've been talking about this evening, is designed to study both the oceans and the atmosphere. Important part of NASA's ongoing contribution to research about various aspects of our planet that impact and are affected by climate change. So heading into the launch attempt this week, we spoke with Karen St. Germain about the impact of PACE once it's on orbit. She's the director of NASA's Earth Science Division. We asked about how the data that's going to be gathered by PACE sent back down to us here on Earth will work in tandem with the other Earth-observing spacecraft like SWOT, which stands for Surface, Water, and Ocean Topography. That spacecraft launched back in 2022. Here's Karen St. Germain on what PACE means for all of us.
The experience of looking at PACE data for the first time is going to be something like putting on glasses for the first time and seeing with clarity. Maybe even going from color blindness to full color spectrum, right? So we'll see the biology of the oceans at this level of precision for the first time. Those nutrients, those plants in the oceans, they get moved around by currents. And that's really where the connection between SWOT, which is going to give us that physical view, and PACE, which is going to give us that biological view, that's really where that becomes powerful. Not only what's there, but how is it moving, where's it going, and why is it there?
Our thanks to Karen St. Germain for her time and talking with us about PACE. We're going to dip back into our conversation one more time as we enter into the final minutes of the count here. We're now T-minus 12 minutes, 13 seconds and counting. Coming up, the next milestone here for readiness of the Falcon 9 rocket will be the chill down of the 9 Merlin 1D engines at the base of the vehicle. It involves flowing a small amount of liquid oxygen through the plumbing and the turbo pumps, which will help protect them from the risk of thermal shock and damage during the startup sequence. Yeah, we can bang that out real quick. Apologies for the crosstalk. The user error hitting the wrong button. We're just talking about going back to the trajectory since we've gotten quite a number of questions about it and it's a bit rare. This will be SpaceX's 12th southern or polar trajectory launch from Florida's Space Coast. So let's go back and review that one more time before we come to the liftoff of the Falcon 9 rocket. As mentioned, the Falcon 9 will be flying in a southerly trajectory, heading toward the Caribbean.
Spacecraft is on internal power.
Hear that call out from SpaceX, another good milestone there. Falcon 9 will curve around Florida and it will fly over Cuba. Before that, though, the payload fairings will splash down a little bit north of Cuba there, as you see on the trajectory map provided by Adam and Steven. The recovery vessel Bob is going to be scooping those up out of the Atlantic and bring them back to Port Canaveral, where they will be turned around and refurbished for future flights. And this will be a return to landing site mission. which means that once the rocket launches from Slick 40 over at Cape Canaveral Space Force Station, booster will perform a flip maneuver and head back to landing zone 1 for a land landing. So if you are on Florida Space Coast or have some friends or family that are here, you might want to give them a heads up that they will likely hear a sonic boom as the booster is coming back in for an LZ-1 RTLS, return to landing site operation. We're now T-minus 9 minutes and counting to the planned liftoff of the Falcon 9 rocket, getting right down to at less than 2 minutes until the engine chill down sequence. As we're coming into this final minutes, appreciate the more than 5,400 of you that are watching with us live. If you haven't already, be sure to hit the like button to allow more folks to find our coverage as we get into these final minutes of the count. Also want to thank one of our wonderful channel members, Nelson Reyes, for a very generous $20 super chat. Thank you, Nelson, for that and for your ongoing support with channel membership, who says, thanks again, Spaceflight Now, for the remarkable launch coverage. We are more than happy to do it for you and really appreciate you helping support us, Nelson. Thanks for being with us this evening.
Engine chill has started.
Now T-minus 6 minutes, 49 seconds and counting. Heard that call out for engine chill. Things continuing to progress nominally towards the planned launch of the Falcon 9, supporting NASA's PACE mission.
Stage 1 RP1 load is complete.
Hear that call out that RP1 load, or the rocket grade kerosene, is now fully loaded on board the Falcon 9 first stage. So we're coming up on the final 6 minutes of the count.
Falcon 9 tanks are pressurizing for strong back retract.
As you hear that call out, SpaceX is getting ready to open up those clamp arms underneath the payload fairings and bring the strong back about 1.5 degrees away from the Falcon 9 rocket, where it will stay in that position until liftoff, when it will pull back in a much more rapid fashion. We're now 4 minutes, 30 seconds away from planned liftoff.
Starlink retract has started.
You hear that call out? We'll see the clamp arms underneath the payload fairings open up momentarily now. We are now T-minus 4 minutes and counting. As we come into the final minutes here, I want to thank a few more folks for your support. Really appreciate it. Thanks to RPM for Years for a $2 super chat saying, "Go Falcon, go." $2 super chat from Janine. Thank you so much, Janine. Really appreciate that.
LD, this is MLM on Countdown Net.
LD.
Pace is go for launch.
Copy.
And we hear that great call out that the PACE spacecraft is primed and ready for launch tonight, as we are now less than 3.5 minutes away from the planned liftoff of the Falcon 9 vehicle supporting it. Of course, we'll get the call out that the Falcon 9 is go for launch from the launch director, Tim Dunn. That's coming up T-minus 45 seconds. I want to quickly give a thank you to Kenny Gurley for a very generous $10 super chat. So we are now less than 3 minutes away from the planned liftoff of the Falcon 9 rocket supporting NASA's PACE mission.
Stage 1 LOX load is complete.
As we hear the call that Stage 1 LOX loading is wrapped up, the final milestone now is for Stage 2 LOX load to be complete. Closing in on a fully fueled Falcon 9 getting ready to launch. This will be the 8th time SpaceX has supported a mission for NASA's Launch Services Program, LSP, based here at NASA's Kennedy Space Center. This will also be the 12th polar orbit launch for SpaceX from the Cape. Two minutes to flight.
Stage 2 LOX load is complete.
Stage 2 LOX load is complete.
And we now have a fully fueled Falcon 9 rocket as we come into the last minute 30 of the count.
Ground gas closeouts.
And that venting you're seeing is the ground gas closeouts as they're clearing the fuel lines, getting ready to send this rocket on its way, send this PACE spacecraft to a sun-synchronous polar orbit. Now coming up on the final minute. T-minus 1 minute to
Falcon 9 is in startup.
Falcon 9 is startup.
Coming up on Tim Dunn's call for go for launch in about 5 seconds.
SpaceX launch director, go for launch.
Go for launch.
And we hear that call out. We are go for launch. Falcon 9.
T-minus
The
30
11th
seconds.
flight for SpaceX this year. We're now less than 30 seconds away from the planned liftoff of the vehicle. 20 seconds.
T-minus 15 seconds. T-minus
Here we
10,
go. 10,
9,
9,
8,
8,
7,
7,
6,
6,
5,
5,
4,
4,
3,
3,
2,
1.
1.
Engine
And
ignition.
and liftoff.
Liftoff of the Falcon 9 rocket,
SpaceX
supporting NASA's PACE mission, getting ready to
NASA.
explore and study the oceans and the atmosphere above. The Falcon 9 rocket has cleared the tower.
Vehicle
Now coming up on
right.
30 seconds into flight, let's listen to the roar
Unfortunately,
nine Merlin 1D engines.
power.
Now 50 seconds into flight. Tracking team working hard to keep the Falcon 9 in frame. This view from Chuck Briggs as the vehicle climbs through some clouds. Falcon 9 now traveling faster than the speed of sound. It passes through 1 minute into flight. And max Q, the point of greatest aerodynamic pressure on the vehicle. Now coming up on a minute 30 into flight.
MVAC engine chill has started.
That call out to thermally condition the Merlin vacuum engine to support its burn. Some great tracking views from our friend Pete Carstens with Max Q Productions. See, this curve here is the dogleg maneuver, as we previously mentioned, for this polar orbit launch. Now a little over 2 minutes into flight. Coming up on the next milestone at T plus 2 minutes 19 seconds will be MECO, main engine cutoff, followed by stage separation, and then the second stage engine start. The boost back burn will begin shortly thereafter. You see MECO.
MECO.
Stage separation.
Stage separation confirmed.
And you see the ignition of that Merlin engine.
Back ignition.
Oh wow, and you can see the glint of
And back ignition.
booster.
Stage 127. Stage 2 ignition.
Some great tracking shots this here from our friend Pete Carstens. We were seeing onboard views from the Falcon 9 vehicle a moment ago.
MECO. Stage separation confirmed.
Some great views from our tracking team here around Central Florida. Now 3 minutes into flight. Falcon 9 first stage still in the midst of the boost back burn. That burn will end right about now.
Stage 1 boost back shutdown.
We saw the engine complete that firing. And we're getting some onboard views from the Falcon 9 second stage, that Merlin vacuum engine continuing its burn, powering the upper stage of the Falcon 9 vehicle with the PACE spacecraft on the other end, of course. Coming up on fairing deployment in about 10 seconds. Falcon 9 second stage making its way for a flyover of Cuba.
Fairing separation confirmed.
And we see those fairings falling away. The PACE spacecraft now exposed to the vacuum of space for the very first time. A little over 4 minutes into flight, you can see we have our booster countdown clock also in motion. Just a little over 3 minutes until that first stage booster makes its touchdown back at landing zone 1 here at the Cape. We have our cameras trained and watching for it. That first stage entry burn set to begin at T plus 5 minutes and 51 seconds, just a little over a minute from now. Appear to have a nominal burn on the Falcon 9 second stage. As the first stage continues to make its way back down towards the Cape. Now a little over 5 minutes into flight.
Nominal trajectory.
With a call from SpaceX that both stages are following a nominal trajectory. Some great views from on board the Falcon 9 first stage here. Coming up on the entry burn, now less than 10 seconds away. You see the lights of Florida's Space Coast as the booster comes back down.
Stage 1 entry burn startup.
The call for the start of that entry burn and some brilliant views from Pete Karstens. Seeing that booster
Stage
coming
1
back.
entry burn started.
Now a little over 6 minutes into flight.
Stage 2 FTS saved.
Stage 2 FTS saved.
Stage 1 entry burn shut down.
And that's the
Stage
end
1
of the
entry burn shut down.
FTS is saved.
That call out the flight termination system has saved. No longer needed as the SpaceX first stage booster making its way back down towards landing zone 1. That landing coming up in less than a minute now. You see the countdown on the top right hand corner of your screen. Don't go anywhere. We are about 45 seconds away from that first stage booster landing. Landing burn starting in just seconds.
Stage 1 transonic.
Stage 1 transonic.
Stage 1 landing burn.
Stage
Call
1
for the
landing
start of the
burn.
landing burn. And our Adam Bernstein's got it on the tracker. Well done, Adam.
Stage 1 landing burn deploy.
Landing leg deploy.
Stage 1 landing burn test down. Stage 1 landing burn confirmed.
Stage 1 landing confirmed.
And we hear the call outs, we see the video. The first stage booster, tail number B1081, is 4 times up, 4 times down. And now we move on to the second part of the mission as we're hearing that sonic boom here at the press site. Now 8 minutes into flight. Coming up in just a little over 2 minutes from now, T plus 10 minutes and 20 seconds, we'll have the second stage engine cutoff, SECO 1. Will end the first and only burn that's happening on the Falcon 9 second stage prior to the PACE spacecraft separating, heading off into its sun-synchronous polar orbit. Coming up on 9 minutes into flight. Less than a minute and a half away from SECO 1. Following that, the Falcon 9 second stage will coast for just a couple of minutes before the PACE spacecraft deploys. All in all, this is a fairly short mission for SpaceX. Part of why they were able to perform. And we're hearing from our friend Pete Karstens with Max Key Productions. Saw some great views from him that car alarms were set off all the way down in Vieira, which, for those not familiar with the geography of the Florida Space Coast, is about 40 or so minutes south of where we are if you take 95 all the way down. So quite a ways to be setting off car alarms, which is not terribly surprising since this was a southern trajectory launch. So heading down along the path towards the Vieira area, but still quite a reverberation for that sonic boom. Coming up on SECO 1 momentarily.
MVAC shut down.
And you heard that call out? You see the glow of that Merlin vacuum engine starting to diminish as the shutdown sequence gets underway. Coming up on PACE spacecraft separation in just a little less than 2 minutes now. T plus 11 minutes, 25 seconds and counting. Less than a minute away from spacecraft deployment.
Engine nozzle, stage 2 still glowing just a bit.
There you see the PACE spacecraft getting ready to separate from the Falcon 9 upper stage. It's coming up in about 20 seconds from now. Should be seeing spacecraft separation any moment now. And there we go.
Payload separation confirmed.
And with that,
Separation confirmed.
on its way. See there at the top right
Payload
corner
separation
of
confirmed.
PACE, the solar panels, those developed by Rocket Lab. Those are set to deploy fairly soon following separation here. PACE will start drawing power to boot up all its systems. It'll spend the next few weeks here getting everything configured. It'll start sending back images fairly soon thereafter. Once it gets everything configured over about 60 or so days, then it'll really start being able to send back good high-resolution data and imagery. As we were discussing earlier, all the information that we're hoping to learn about the phytoplankton, their movement and their impact to all of us around the world. Just one piece of what the PACE spacecraft is designed to do. Now a little over 14 minutes into flight. You can barely see the PACE spacecraft anymore as we're now pivoting to inside launch control for NASA here. Taking a look at the NASA team that helped support this mission for the Launch Services Program. This is Hangar AE over on Cape Canaveral Space Force Station. Of course, the SpaceX side of the equation is over at Hangar X at NASA's Kennedy Space Center. This is the LSP specific room here that you're taking a look at. That is the logo of the Launch Services Program that you see there on the back wall as teams are awaiting confirmation of the solar array deployment, which it appears that they have just received. Certainly good news for the PACE spacecraft here. once the spacecraft is on orbit, this is what it will look like once the solar array is deployed. PACE has a nominal mission life of 3 years, although it has enough fuel on board to last up to 10 years. And every 3 years or so, they will go back through and review the health of the spacecraft and determine if they are in a position to extend its life for another 3 years beyond that. So PACE could have a long history as part of NASA's Earth observing satellites. You see the strong back the strong back is coming up right there at pad 40, part of SpaceX's process of turning around the pad as quickly as possible to support its rapidly increasing launch cadence. Next mission we're expecting to see from this particular pad is another Starlink launch, the Starlink 6-39 mission. Now T plus 18 minutes, 13 seconds and counting into this mission. The teams at NASA LSP are awaiting to confirm that the spacecraft is power positive, that the solar array has deployed as intended, and the PACE spacecraft is drawing power and can begin to boot up its systems and start the configuration process. As we await for that confirmation, we're going to go ahead and stay with you until we get that. Do want to talk about another facet of this whole process, which we mentioned that PACE is a part of an ongoing line of Earth observing spacecraft, and so unsurprisingly, NASA is also looking towards what is on the horizon, bringing more online to help gather details and data about our Earth. And so we want to go back to part of our conversation with Karen St. Germain from NASA's Earth Science Division, who has a little bit of an explainer on what's coming up now that PACE has launched.
The very next one that we're working on is called Glimmer, and it will be a similar kind of capability, but it will be in geostationary orbit. That means it'll essentially be dwelling overhead, really focusing on the Gulf, the Florida coastline, and the Amazon river drainage. So the algorithms, the science that we develop under PACE is already being transformed into science and algorithms and data products that will come along with Glimmer. That'll be a few years from now. Looking a few years beyond that, we are just starting now to build a couple of really important missions. One will be, they're both part of the Earth System Observatory. One of them is called the Surface Biology and Geology mission. That is going to be the next generation. So it will stand on the shoulders of PACE in terms of really understanding global biology. And we didn't talk about geology here, but understanding mineral composition can be done with the same technology. So that's that mission. A second Earth System Observatory mission is the Atmosphere Observing System, that really will focus on these questions of clouds and aerosols and those interactions. So yeah, a number of missions coming up that are anxiously watching PACE, and PACE will inform how we build those missions, how we do the science, and how we deliver applications.
Want to once again thank Karen St. Germain, the director of NASA's Earth Science Division, for spending some time with us ahead of the launch, giving us a glimpse into what PACE has on tap for it, as well as what's coming up next down the line. Still awaiting confirmation that PACE is power positive, so while we are waiting for that, want to thank a few more folks for their support of our live coverage this evening. Some of these coming in before, during, in the midst of the launch, so forgive the timing of this, but do, of course, want to acknowledge all these wonderful folks for their support and helping us do what we do here at Spaceflight Now. Our channel member Josh King with another $10 super chat. Thank you for that, Josh. Saying, go Falcon9, go PACE. Yes, indeed, and it is on its way. Alina Hawk with a very generous $20 super chat. Thank you so much, Alina. Says, peace and love to everyone from the Olympic Peninsula in Washington State. And hello, and our best and warmest regards to everyone there in Washington. Want to welcome Susan Enderl. Apologies, Susan, if I mispronounced your last name, but welcome aboard to channel membership. Includes, of course, a number of perks, including being able to watch all of our Cape launches in 4K, discounts at our online shop, shop.spaceflightnow.com, as well as access to member-only videos here on YouTube. And our channel member Norman Reitzel with another $2 super chat. Thanks for that, Norman. Ask as much as possible to please include telemetry. And of course, we certainly try to. We want to make sure that we bring in the trajectory map in the run-up to the PACE mission and all the launch as much as possible. We're a little bit at SpaceX's discretion when their telemetry data and map gets brought up. Perhaps we can work on a way to try to keep something more continuously in our stream. We can talk about that offline and see if that may be a possibility. I don't know, something to troubleshoot if we might be able to work that out. Thank you for the suggestion. Thank you for the support. Taking a look back now inside Hangar AE, NASA's launch team. Again, continue to track the progress of the PACE spacecraft as we are waiting confirmation that PACE is power positive, the last milestone here in the progress of this mission so far. Now T plus 24 minutes, 9 seconds into the count. Things seem to go well for SpaceX on this whole venture. You see there an empty pad, the transporter erector brought back upright, and a glowing crew access tower, which we expect may come into play later this year, although SpaceX has not said specifically for what mission they may use this for. There are a few more crew flights coming up on SpaceX's docket left in 2024. Of course, there's the launch of the Crew 9 astronauts later this year, no earlier than August. Did have that crew announcement that was made recently.
from stage 2 were incredible. Not only watching Pace, exciting mission that we've heard all about this morning, but that video just, it was exciting to watch that and be a part of this. And I know the Pace team is anxiously awaiting that power positive information. But we got Pace where it needs to be and on its way. So this is a great start to the launch this morning.
Jim Free, NASA's Associate Administrator, is here on hand. He is there in the control room. You can see him in the second row in the middle, the fourth from the right. All along the first row, the teams from the Goddard Space Flight Center. They have a team back at Goddard that is online as well, the Mission Operations Center, and that's where the spacecraft will be commissioned. And it is also where they are sending commands and receiving telemetry at this very moment.
Goddard Space Flight Center, also the location where the Pace spacecraft was built. And they contributed the ocean color instrument, the primary instrument for the Pace spacecraft. T plus 27 minutes, 42 seconds.
I spoke to Pace Test Director Nusha Hagani, and she relayed to me that these are some tense moments. As a team watches and waits to get that confirmation that the sun is shining on the solar arrays and it's oriented in the correct direction. Once they get that confirmation, I'm sure we'll see a reaction from the team.
But the spacecraft development and to cover the costs of...
According to the milestones, we are at the point in which the Goddard spaceflight team can command the spacecraft after waiting for a period of time as it came off of the second stage. That's so they don't get anything mixed up with the second stage of the rocket as it's going into a disposal burn and the spacecraft is going on into its orbit. T plus 29 minutes and counting. We are now into the moment where we would expect the milestone of power positive to happen, but we also know and have been told by the Goddard team that it could take a little longer.
Yeah, Daryl, I know as the spacecraft team is waiting for this information, the launch vehicle team has been doing a quick look on how stage 1 and stage 2 performed today, and so far everything is reporting in as perfectly performed launch vehicle today. As we saw in the video spacecraft step, Falcon9 delivered Pace where it needed to be. So that's good news on the quick look of the launch vehicle. And I know that the Pace team is excited to be where they are, just waiting for that power positive confirmation.
Great report out there, Mick. And as Pace was delivered to an orbit 674 kilometers, about 400 miles above the Earth's surface.
Those
Pace has 10 years of fuel on board to do its observations and report back its scientific data. But you never know with these satellites. They can go a lot longer. Just depends on how they use their fuel.
The lights that you're seeing here at the bottom of the screen near the transporter erector, just want to make a note of that. We got some crews out there at the pad already surveying things, giving the pad a checkout. We are still waiting confirmation that the vehicle, the spacecraft's pace, is power positive. As you've heard from NASA's Daryl Nail, the row folks at the bottom of your screen, closest to the left, are from NASA's Goddard Space Flight Center, the team that will be managing this mission, also the team that built the spacecraft. At this point, they should have received confirmation that the spacecraft is power positive, but as Daryl has noted, that process could take slightly longer than what was estimated. We're now T plus 33 minutes, 10 seconds and counting. These are the solar arrays in question that were contributed by Rocket Lab. These are ZRJ solar cells, part of the commercial contribution of this mission. Rocket Lab describes these as ZRJ radiation hard solar cells.
All right, you can see the applause there in the Mission Director Center. The spacecraft team happy to report that they have power positive on the PACE spacecraft. Again, the final milestone, power positive on the solar arrays on the PACE spacecraft. That's great news. Congratulations to the PACE team.
Absolutely.
This is a big moment.
Successful mission.
And they're here, the call out that we've been waiting for, that the spacecraft is power positive, the last big thing that they were awaiting. That now the spacecraft is able to draw power and start getting on its way with its primary mission. Now NASA Goddard Space Flight Center can claim mission success up to this point. You can see some very relieved faces in the room. As we were mentioning, these solar cells were contributed by Rocket Lab. They're important because we'll actually see them fly in another piece of crucial NASA architecture, as they'll be contributed on the power and propulsion element of the forthcoming Gateway Lunar Space Station, a key element of the Artemis architecture, helping NASA get humans back to the moon in a sustainable way. Taking a look back one more time inside the control room here at Hangar AE. One other commercial contribution to this mission, want to note here. These Coarse Sun sensors, 13 of these contributed by Redwire Space, headquartered just up I-95 in Jacksonville, Florida. The sensors, along with the spacecraft's star tracker, work in tandem as part of PACE's attitude control system, helping to keep the PACE spacecraft in the right orientation as it conducts its important science observation. Redwire has similar sensors on the Psyche spacecraft, as well as the New Horizons mission and the Parker Solar Probe. So, very important component of the spacecraft in use here. Before we go ahead and close things out, want to welcome Michelle Potter to channel membership at the pad leader level, bringing in some of our photos from our launch team that were out tracking the mission tonight.